Hello everyone, my name is Imtwana and we have a question right here we have to solve. This question is just one of those questions, okay? I'll say one of the weird questions. There's a lot of ways that I'm going to show you how I'm going to solve this. I'll use two methods. There's actually three methods that I can show you this question. But for today, I'm going to show you two methods. And then I want you to tell me which method that you think is correct. Because I want to solve this question. And then there was a lot of people had to say what they had to say. So I'm going to use both two methods, and then you tell me which method you prefer, or how would you approach this question, okay? So what I'm going to do first, let me start with the first method. I'm going to do the controversial method first. That a lot of people say, oh no, you, because I once did this question and a lot of people came at me. So now let's start with the controversial question. Now we're going to say, I'll start with this one. So I'm going to apply logarithm on both sides because I have exponential there. I'm going to apply log on left, so we have a 2 log here and log here before anything. Log, but on the top there I have x. So say log x, equal sign. And then here I'm going to write log also. And then 4 and x. But remember we have a laws of the logarithm. The law for logarithm says, if you have a log a times b, this same as say log of the first one, since it's multiplication, then you add here log of the second one, or you can use log, but let me just use a log. So I'm going to apply here. I'll say log here, just a log is I have 2 power x. I'm going to apply the rule right here, so this is going to become log 4, but since there's a multiplication here between, just like a times b, I'm going to say plus log of the second one. Okay, so now what is 4? 4 is 2 squared. So instead of this 4, I'm going to say 2 squared. So I'll say, well, instead of this 4, I can say log 2 squared, and then we're going to plus log of x. And then here on the left, I'm going to take the, okay, I'll write log log 2 power x. So what I'll do, I'll take this x to the back, and I'll take this 2 to the back. So here I'm going to write x, and here I'm going to write 2. So this is going to become, I'll write x here, so I can simply raise, because we have a law which says if you have a log, let's say a power b, this can comes back here and they say b, and then log of a. So what I want to do, I'll take this power behind here, okay? And remember, since there is no base here, then we're going to say log base 10, okay? For example, if somebody give a log k, if there's no base here, you say this is under base 10, automatically you assume. So I'm going to take this x back, so here I can say this is under log 10, and under log 10, okay? Then I'll take this x behind, I'll say x here, and then I'm not going to write anything here, just like how the law say. But the reason why I just do right here because of the space. So I'll write here my 2 behind. But unfortunately for the last one, I don't have no power, so there's nothing I can do. So what I'm going to do right here, this is x log 2, 2 log 2, log x. So which are similar here. If I can look careful, this is log 2. And this is log 2. Under base 10, log 2 under base 10. And this is log x, this is x. So we know in math it's good to put like terms on the one side. Just a basic algebra. So I'm going to take this one to the left. So if I take to the left, then I'm going to have, I hope you can see here, let me just erase it, because since I know it's 2x, 2 power x equal to 4x. So then this is going to give me, on the left hand side I have x log 2, and then we have this 10. Tag this to the back of equal sign. Since this is plus, when you jump the equal sign, it's going to become negative. So it's going to become negative 2 log 2, and under this 10, and then we have the equal sign, and then log x under this 10. So now, then the next thing, this is log 2 and this is log 2. So I can factor it out. So I'm going to say I'll take out log 2 I'll take out log 2. So if I take out log 2 here, but it has the end up as 10, then I'll be left here. See, this one went out. Let me put bracket here. Okay, so then here, I'm going to be left with x minus 2, and then on the right hand side, just log x and the base 10. So now is where I'm going to cause some controversy, where people say, how could you do that? Okay, so now let me ask you this. If you have, for example, if you have, say, log, here's where the problem is going to start now. And then I want you to tell me, so this is the fifth method. I have not finished yet. I'm going to finish up, and then I want you to tell me at the end which method you think is correct. If you have, let's say, log x, let's say equal log 2. What the value of x there? Is it correct to say x equal to 2? Is it correct or is not correct? You tell me. Because if these things are equal, in my opinion, I could be wrong, then I will assume for them to be equal means the value of x must be 2. If it's another value, means they cannot be equal. So in other way, I can say the value of x here equal to 2. Because there's a log, and then whatever I have here, there's no base, means it's under base 10. So if I have, let's say, log, okay, now let me bring your confusion a little bit, right? So now let's assume this is, let's say, log x minus 1 under base 10. So what the value of x is? Equal, here there's an equal. Is it correct for me to say, since same log on the base 10, is it correct for me to say x minus 1 equal to 2? And then I can take this over, say x equal to 3. Now let's test to see if it's true. If I take 3 right here, it's going to be 3 minus 1 equal to 2. Means it's going to be log under base 10, 2 equal to log, 2 equal to 10. Means yes, it's true. So if that is true, and if that's the case, then what if I say, since this under base 10 and this under base 10, so then I'm going to say I'm only going to take this one here, equal. Means 2 x minus 2 equal to x. Now I want you to tell me if this is correct or wrong. And then I'll say 2 times x, 2x, 2 times 2 minus 4 equal to x. And then I'll take x back. So 2x minus x equal to 4. 2x is going to be x equal to 4. So x equal to 4. Let's test to see if it's true. So now I'm going to say, okay, let me test and see if it's true. And then I'm going to show you another method now. So the question was 2 power x, right, equal to 4x. Now let's test. Let's test to see if it's true. So the value of x you say equal to 4, right? Now 2, what the value of x? 4. On the left hand side. So what is 2 power 4 equal to 16? Now let's see right hand side. 4 times value of x. Value of x equal to 4. So 4 times 4 equals 16. So 16 equals 16. So I want you to tell me, like, okay, what are your thoughts on this? Now let me do another method. Okay? Which I believe maybe some of you, or some, because here a lot of people might be watching. So some of you might agree, or some might not agree. So it depends on your opinion. Let me do another method. Method 2. So method 2, 2 power x equal to 4x. And then I'm going to do also method 3, 2 power x equal to 4x. So I'm going to apply my logarithm throughout. So this method number 2. So if I apply logarithm here, it's going to be log. You remember you have a 2 power x equal to log 4x. But a log 4x means I can separate from the law of logarithm. We know I can say log 4 plus log x, because according to the law of logarithm, we say log A times B equal to log A plus log B. You can simply separate this. So here, I'm gonna say this same as say log 4 plus log x, but so I can say log 4 plus log x equal log 2 power x. 2 power x. But what is 4? 4 is 2 squared, so I can simply remove this 4 and say 2 squared. 2 squared. But then I'm gonna take this x to the back and I'll take 2 to the back. So then I can say x go to the back, front or back, it depends. Some people they say front, some people they say back. So it depends how you could call it. X log 2 equal to log 2, because you take this in front or you can call behind, however you can say log x. So these are like terms. Log 2, log 2. Let's put them on one side. See? This is log 2 and this is log 2. So we can take this to the left. So I can simply say x log 2 and then comes back, it will become 2 log 2, and then on the right hand side equal to log x. So we see like terms here. What is the like term? The like term is log 2 and log 2. So we can factor this out. So if you factor out means you're going to be left with x minus 2. So I can simply solve that right here on top. So let's just make some space here. So I'm going to say log 2 is going to come out. I apologize, now pen is finishing there. Log 2 is going to come out. So here I'll be left with x minus 2, because log 2 went out to factorize. We factorize. So then we're going to be left with 2 here. Okay? And then equal sign. And on the right hand side is just log x. So now look how I'm going to solve now. Remember, here is where the problem came. It's no problem came at first. I did another approach where I say I'm going to introduce base 10 and then I want to use base 10. So what I want to do now, I'm not going to say this stuff like how I did before. I'm not going to use that approach because some people know they might contradict with me. This and this one. I'm not going to. So what I'm going to do, I'm going to take this to the left. Let's take to the left. So let's just erase here and make a space. Okay, and then, so I'm going to say, well, I'm going to take all this stuff to the left. Say log. Okay, remember these are the base 10. All of this stuff, which is 2 x minus 2 minus all of this log x and the base 10, and then equal, there's nothing here, we're going to write our 0. But remember, from the law of the logarithm, we have, they say if I have a log a minus log b, this same is say if you have a log of a first group minus second group, this is same as say log of whatever you have here. If it's minus, you divide. So you take log of a, divide log of b. Let me say clear here, right? So you take this one over there. This is not equal to log of a over log of b. Two different things. Is not equal. That's what I say this is not equal. But it's equal to, this is equal to that. Means you only divide the letter or whatever you have in front of the log, a over b only. But you don't take log a over log b, no. So what I'm going to do here, I'm going to say log, since it's minus, I'm going to say under base 10, and then I'm going to say 2 x minus 2, and then over x, and then equal to 0, because we use that law right there. So when I'm right here, what I'm going to do, we have a law of exponent. So the law of exponent is very, very easy. Let me show you here. If you have, for example, a and then c, let's say equal to k, any letter. So according to the law of exponents, the law of exponents you only apply when you have a log on one side. Only when you have a log on one side, and another side it must be something which has no log here. So what you do, you push this here, and then you write your a, only a equal, this c is going to come here, and this is going to become as a power. And this log disappear. For example, like you just push it here, See, C came here, and then this is going to go as a power K, and this A you write, and log will disappear. For example, let me give you an actual example. Let somebody give you log x square, and then here they give you 100 equal to 0. So what I'm going to do, I'm going to apply exponential there for me to get x. Because here, there's a log, there's nothing. So I'm going to write my x square on the left equal, you write your 100 here, and this 0 is going to become as a power. So x squared equal to 100, and then I'm going to square it, I'm going to square it, so the value of x equal to plus or minus 10. So I'm going to use the same approach here because I have a log on one side, I have a base, and then I have whatever I have. So I'm going to push this 10 on the right hand side. It's going to become 10 power 0, and then on the left hand side it's going to be 2x minus 2, and then over x. But any number plus 0 equal to 1. So this is going to be equal to 1. Any number plus 0 equal to 1. You can plug in the calculator, you're going to see. According to the law of exponent. So what I'm going to do, I'll just cross multiplication here. I can just multiply by x, multiply by x. So we can cross multiplication. Or you can say, well, I can say over 1 and then multiply by x, multiply by x. Or you can simply cross multiplication. Either way, however you prefer. So then I'm going to say 2x because I can open this bracket. So it's going to become 2x. 2 multiplied by -2, -4. Equal. Okay? This times that one means this times 1 is going to be the same thing. Means 2x minus 2 times 1, which is going to give us that one. And then x times 1, x. Or let me just do slow for a slower pace. 2, x minus 2, times 1 equal to that. And then x times 1, x times 1. So 2x minus 4, because you open the bracket equal to x. So 2x, this x comes back, and then this 4 goes over. So x equal to 4. And x equal to 4 means when you plug in original equation, it's going to give us the same answer, which is going to be correct. So now, if you put back in a given equation, which is 2 equal to 4x. If you plug 4 here, look, 2 is 2. Power, 4. What is 2 power 4? Equal to 16. Okay, now let's go to the right hand side. Right hand side is 4 times 4. 4 times 4 equal to 16. So 16 equals 16. Left hand side equal to right hand side. Look, I want you to tell me now, in your opinion, which method would you go for? I've got another method which I'm going to show you next time. It's okay? But hey, thanks a lot for your time, and I appreciate. Share this video, tell me your opinion, and I'll see you soon. Subscribe, like this video. I got Josh right here, man. So Josh, he said he want to say something about his progress, right? Tell me, how did your progress since when you started, like as far as, transition of learning since when you started up to now?
Well, I've learned a lot more on how to practice maths more, and obviously Amish has told me to practice, and speed is important, so I've been doing a lot of practice on lots of different sums to help me go faster during the test and get better results in the end. So yeah, I've been improving and hope to improve even more.
Okay, and how was your marks when I met you? Please just be honest with me, like before I met you, how was your score before I met you?
I was getting about 60%. 50%.
In your last test, how did you score?
My last test, I got 85, 86, I think.
85, 86.
Yeah.
So there's a lot of improvement, right?
Yeah.
Okay.
Hello.
How you doing?
I'm good.
I'm fine, thanks, man. How's your progress so far?
My progress is good. It's going good. I've improved a lot throughout the whole year. I've been going up, improving the whole time. My test, the past test that I just wrote, I got 84%, so I'm happy with 80%, but I'm always looking to improve, so yeah.
Okay, so I know you aim always to score 100 on that. If you had to give advice to, to grade 11 student, 10 or junior high school student, as far as how to study physics or how to perform better, is condensed, is possible, is condensed that you could advise to them, how would you tell them?
So physics is all about your formulas and obviously getting it right, because sometimes questions can have a lot of detail inside of them, so you have to make sure that you plug in the right values at the right places.
Thank you for giving us clothes, thank you for looking after us. We appreciate your clothes and your shoes you're giving for us. See that he give us clothes. We don't have clothes, but he's giving us something. He's looking after us.
Okay, Shamil, tell them, when did you last go to school?
I was going last year, I was last time I was going to school.
Which grade was that?
I was grade 9.
That was grade 9.
Yeah.
That's the last time you went to school. So you know you can become engineer. You can become scientist, right?
Yeah.
I was also on the street. I think I tell you every time, right?
3 years you said.
3 years I was down the streets, okay? So I was just like you, okay? I was also on the street for 3 years. But I came out of the street and that changed my life, okay? So, yo, what's up, man?
Yeah, what's
How you doing, bro? Yo, what's up, man? Hey, what's up? Okay, cool. You see, I was also on the street for 3 years, okay? Say hello to the brother, man. This is my brother, man. How you doing, man? Cool. So I got a lot of clothes for you, okay? You remember I told you I was gonna go and get clothes, shoes. I got some food. I'm gonna buy you some food, okay? Huh? Huh? No problem, man. Come on, man. You know brother got your back. What did I tell you last time?
Yes.
Okay, cool. So Shamil, he said he stopped last year, right? Because
If y'all want to reach out, how do we pronounce your name? Let me try. Wait, let me try. Okay. Mtwana Wabantu. Okay.
yes, watching here, you know, they can learn from me that, you know, relationship is very, very important. And, you know, sometimes don't look about today. You might scam somebody maybe $1, but you don't know who that person is. You know what I'm saying?
Well, this is the thing, too, that for many a years, I've always been that person to try to link, hook up, pass on, or help people, because I used to know a lot of people, right?
Hore o re thuse re tlhoka thuso ya gago Mr. Mtwana wa bantu ke a leboga. Everyone, my name is Biko. The reason why I'm doing this video is because of Mtwana wa bantu. It's because of the help of Mtwana wa bantu. Mtwana wa bantu is a nice guy who help people like me who don't afford torture.
And that's exactly what you're saying, is that, you know, these people who are scammers and try to get over on people, and all they're doing is living from day.
Is that Mike? Is that, hold on, it look like some, what's your name, bro, at the bottom right? Matwana. Right? Mtwana.
I don't know how to say it.
I apologize. My mic was muted. I apologize. I'm sorry.
It's okay. What's up, y'all?
Not much cool. Hey man, I watch you all the time. I just want to give my thanks to you, man. Cause me and my lady.
You said kind of when you hear that.
And I'm going to be working out the net electric field strength on point A, basically.
Thank you. Can you really do those questions?
Yeah, can do.
Okay, let's see. Thanks. So, how did you know all this stuff?
Mr. Hamish taught me all the steps. It was a bit hard first time, but when you get used to it, it becomes very easy.
If you had to give advice, what advice would you give to the people or to the students?
Trust Hamish.
Why would they trust me?
No, because it's really good. It actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Hamish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
How many days have you involved in this program of coding?
Of coding? Well,
Yes.
for 2 days.
For 2 days. Do you enjoy it?
Yeah.
Enjoy.
Yeah.
Okay, cool. So let's get into it. So which computer language is this?
Well, this.
So I started coding last year, and the beginning it was very hard. So
This way.
So I practiced a little, and then I was like easier, but it's still tough, but it's still getting there.
And then obviously one question could lead to another question being asked. So you have to take into consideration that you get your first question right before you do the second one, because if you do the first question right, then you have obviously a correct answer. But if you do it incorrectly, your next question that you do could obviously have an impact on the answer that you got in the previous question. So obviously getting the stuff right at the first attempt, and obviously plugging in your values correctly.
Okay. Anything you want to tell?
Always read your question so that you understand it and never guess.
Never guess. You reading, never
Guess.
Okay, very good. So if you have a question or you guys haven't watched at home, send the question, right? Cody, she's gonna solve all the question. Is it right?
Yes.
Okay, thank you so much, Cody. We appreciate it. Hey guys, how you doing, man? It's Hamish and Melissa. So like how we always do. So Melissa came with a surprise today. So she wanna surprise you because they called it up. What you say you gonna do?
I'm going to code how can you apply for your school.
Okay, so what you mean about that? Like
when you're new and then you want to go to school, so then there's like something you have to do before you can get into the school. So I'm going to show you the coding of that.
Oh, so Melissa's birthday is kind of very, and she created a program also. She included her baby. You can see how creative she is.
Yes. Okay.
Let's go.
So can I get your money, please? So over here, if so say now you give him 1,500, then you can go to school. But let's do it quickly again. So 1, 2, 3, 4. 2007, 11. If the amount is less than 1,000, like say now you give them 500 rand, then sorry, try again next time.
Okay, so that's a function of each statement.
Yes.
Okay, Melissa. So, how you doing? I'm fine, thanks. What's your name?
You just said it's 9.
Just skydive, man. Give me skydive. Give me skydive again. Whoa. Oh, so what you doing right now?
Math.
What you math?
Area and perimeter.
Area perimeter. You got tough or easy?
Excuse?
Tough or easy?
It's in the middle.
What you do? This is in the middle. You gotta give it one clear answer. Hard or tough or easy?
It's easy.
Easy. Easy? Oh, my God. It's a little better.
You'll get it. Next step could be a mistake.
So how did you know all this stuff, Nas? Who teach you all this stuff, huh?
So 4.8, we're going to write it into parameter.
Why? How did you know that?
Because the parameter is 4.8.
Okay.
So 4.8 centimeter equal 4 sides. So we're going to divide it. 4 goes inside once. 4 goes inside once. 4 goes inside once. We start first with the first number. 4 goes inside 1. 4 goes into 8 twice.
If I can do it, you